let me quickly give you a summary of the previous video. We started out by wanting to know the function f of x equals sine of x, and we started out by imagining a circle of radius 1. This is radius 1, and we imagine there to be a point moving around the circumference of this circle here, and as it moves around, the theta here, the angle here, increases. Well, if say the point is here and it makes an angle of theta, we imagine there to be a vertical line down here creating a right angle triangle, and the height at any given theta, it's given by sine theta, because if you have a circle, and let's say this is your x and y axis here. If let's say the circle is at this point here, this is theta here, you draw a vertical line down here, the height here, let's call it y here, the height here, which is y, is, well, you know, here you've got to use sine, so it'll be sine theta equals y over, well, the hypotenuse, because from here to here is of radius 1, then this radius here must also be 1. The hypotenuse in this case is 1, and this bit here neatly turns into y. So y here, well, when you have a circle of radius 1, y, which happens to represent the height of this point here, is given by sine theta. So as you move around here, the height at any given theta is given, well, the height is given by sine theta. So if you go back to the original circle here, remember we imagine there to be a point moving around the circumference of this circle, and as the point moves around, let's say it makes an angle of theta here, then the height of this thing here, the height of the point at any given angle here happens to be sine theta. So you can imagine sine theta to be you can imagine sine theta to represent the height of this point as it moves around. So the height here at this point is here. The height at this point is here, and then we from this we manage to jump to a graph. And if you look at it, when a point is here, which means the angle is 0, the height is 0, and when it's at this point here, which is 90, it will be right here. The height will be 1, because remember it has a radius of 1, so that means the height here is 1. That's why when it's at an angle of 90, the height is 1, and when it's in this position here, the height, well, when it's in this position here, the angle here is 180, meaning that the height is 0. So at 180, the height is 0, so it's here. And then as it moves around here, this is 270 here. When it's here, you can see that the height here is negative 1. So at 270 here, the height is negative 1. So it's here, okay. And when it's 360 here, the height is back to normal. You see the height at 360 is like the height at when theta is at 0. So 360 in this scenario is like 0. So it's right here, and then the cycle goes back again. So 450 is like another 90 degrees. So you can imagine, well, you can imagine you can imagine 450 to be like this. This is 90, 180, 270, 360, and then 450 will be another 90 from 360. So what you can imagine 450 to be this, so see, this is 360 already. 450 would be right here, back to 90. So 450 is the equivalent of this bit here. Well, as it turns out, that the the graph will look something like this. Hang on. You see, 360 here is one cycle, and then it's just gonna after 360, it's just gonna repeat. It's just going to repeat itself. So when if you get yourself a graph plotter on the internet and plot the graph of maybe y equals sine sine x, or f of x equals sine x, it will look like this. Okay. Yeah. So get yourself a graph plotter and plot the graph of y equals sine x, and it will look something like this. Okay. And don't forget, you can have a minus. I guess what the minus means. So here, this is the angle. This is when the angle is increasing. Okay. But you can have a minus of an angle. What that means is, well, let's say for here, let's say this angle here, let's say theta here is 30. Okay. Well, minus 30 would be like this. So minus 30 would be from here to here. Okay, so this is minus 30. I guess when you increase theta, it goes in this direction. But when you have a minus, when you have minus theta, it's going the other way. So theta being 30 would be around here. This is 30. Minus 30 would be, I guess, would be around here. So this here is minus 30. Okay. In the next video, we will look at f of x equals cos theta, or we can imagine it as, sorry, f of x equals cos x, not theta. Okay. How? So yeah, in the next video will be, I can't actually say theta, because when you say a function f of x here, it means you're going to do something to the x, and then it doesn't make sense for me to say, well, when you see f of x here, what's inside the brackets? It means that you're going to do something to the x. But then if you look over here, there's no x, so this here doesn't make sense. That's why you have to say cos of f of x equals cos of x. It means I'm going to get this x here and then put it into here. Well, you cannot say f of x equals cos theta, because here you're looking at it and you're seeing, oh, I've got to do something to the x. But when you look over here, there's no x over here. So this here doesn't make sense. That's why I made a mistake earlier. I should have said cos of x. Okay? Well, in the next video, we will look at f of x equals cos of x.